Hi there, welcome to this tutorial on Maven from In28. In this tutorial, we will use hands-on real-world examples to understand what Maven can do. We will learn different features in Maven that makes web development, application development with Java very easy. We will learn how Maven helps us to automate various things like compilation, packaging, creating a var, creating a jar, running a web application in Tomcat. We will also learn how Maven can be used effectively in combination of an IDE like Eclipse. Let's now understand the approach we are going to use during this tutorial. We will start off understanding what is Maven. What can a Maven help a developer do? The most important concepts in Maven are the project object model and the build lifecycle. We will learn those using the beginner Maven project. The next important concepts in Maven are dependency management and transitive dependencies. We will learn those using the intermediate Maven project. A typical Maven project has a number of dependencies and a number of layers: a web layer, business layer, data layer, and external interfacing layer. These layers are called modules in Maven. We will learn how to create such a project using a multi-module Maven project. In the fourth example, we will learn how to use Maven to create a var. Most of the Java developers work in developing web applications. We will learn how to use Maven to deploy a web application to Tomcat. We will conclude this tutorial by learning a few tips and tricks about Maven. We will learn different commands which would be useful when you are debugging. We will learn what are the best practices in using Maven. Maven is a Java dependency management framework. So we use JDK, obviously Maven, and we use an IDE called Eclipse. Don't worry about installing all this right now. If you have them installed, that's good. But if you don't, it's not a problem. We have a complete installation guide to help you install all these three and getting them working together. The installation guide would also help you to solve any problems that you encounter during the installation. Let's get started with understanding what Maven is and how Maven makes the life of a Java developer or a tester for that matter very easy. When I go to the website of Maven and try to look up the definition, it says something on the lines: Maven is a complete project management tool and a Java application management tool. I understand the problem they have in defining what Maven is. Maven does so many things that it's very difficult to fit it in one box. So instead of trying to define what Maven is, what we'll try to do is find out how it helps an everyday developer or a tester. Let's take a typical Java developer. He writes Java code. This Java code has a number of dependencies. By dependency, we mean the frameworks which I used in this particular project. So let's say I'm developing a web application. Then probably I would be using Spring MVC or struts. Probably I'll be connecting to the database using a JPA, let's say Hibernate. So an everyday developer needs to manage the dependencies of the project. He needs to build the var file. He wants to deploy the var file to Tomcat or Jetty or WebSphere. And he wants to find out if the web application is working fine. And these are all the things that Maven enables you to do very quickly and very efficiently. Before Maven, there was a tool called Ant. Ant is a build tool. The problem with Ant was that you had to manually write code or scripts to do each of these activities. With Maven, you don't really need to do that. We will figure out how to do all these activities with Maven during this tutorial. Maven has this feature called Maven archetypes, which can be used to generate web applications, applications that use Spring MVC, struts, and a whole lot of projects. We will learn about archetypes a little later in this tutorial. Now that we understood what Maven is, let's get started with our first real-time example. The aim with the beginner's Maven project is to understand three things. A. What is the power of Maven? How Maven helps us with little code to do a lot of things. Number two, we'll understand something called a project object model. Project object model or a POM is the base for Maven. We'll understand what it is. The third thing which we'll understand is build lifecycle. What you're looking at on your screen right now, on the left side is my terminal. I'm using Mac, so I launched up terminal. If you're using Windows, then probably you need to go to your command prompt. On the right side, I have opened up the project. The complete source code for this particular project is available for download. The link is below the video. If this is the first time you're watching this video, I would recommend you to just watch the video and try doing the hands-on part the second time you watch this video. what I've done here is I've downloaded that zip file, unzipped it. If you unzip it, you would see 5 different projects, 0, 1, 2, 3, 4. We use array indexing. In the first project, you would see 3 different files. One is called app.java. App.java is a very simple app. It contains a public static void main, and it contains a dummy method, calculate something. The app.test.java contains a JUnit test. If you don't know what a JUnit test is, I would recommend to go through the video JUnit in 28 minutes and understand what unit testing is. We think unit testing is really important part of application development. If you don't know JUnits, that's okay. We'll continue learning Maven. This is a sample JUnit test. The last file I have in this folder is something called pom.xml. This is a basic pom.xml. Let's not really worry about the details of what's in here right now. We will learn what's in here a little later. So what we have in this folder is 3 files, app.java, app.test.java, and pom.xml. What we want to do is we want to build a jar file which contains this particular application, this particular app.java. A friend of mine wants to use this project in his project as a dependency. So what he wants is a jar of this particular project so that he can use that as a dependency. You can think as if we are developing the Spring framework. This is a very simple Spring framework. It just contains one app.java and one app.test.java and one pom.xml. Spring project would be much more complex than this, but you can think as if you are creating a Spring framework and you want to give this Spring.jar to other developers. And that's what our aim is. So I want to create a Spring.jar. So what's my aim? I want to create a Spring.jar. Let's see what are the steps that are involved in creating a Spring.jar. First thing is I have to convert app.java, compile it, and create app.class. The next step is I have to compile app.test.java and create a app.test.class. And compilation generally is not an easy process because to compile a particular class, if the class has dependencies, let's say this particular class is using the JUnit framework. So you have to make the JUnit framework available in the class path. If the JUnit framework is not available in the class path, then it would throw an error, class not found. So compilation itself is a complex thing. So we have to do these 2 compilations. I have to run the unit tests which are present in app.test.java. If the unit tests don't compile or don't run, then it would mean that my project is not really working. So I have to fix the JUnits. The 4th step that I would need to do once the unit tests are successful is I would combine all the class files into one archive and create the Spring.jar. There is a specific format that Java provides with creating a jar files, but there is a command available to do that. So these are the 4 steps. Earlier, what we used to do, and scripts to do that. So we used to write an AND script to compile test classes, to run the unit tests, to combine all classes to a jar. I have seen AND scripts which had something like 10,000 lines of code. And that's where Maven came in. Now, let's say I want to do all these 4 steps with Maven. Let's see how we do that. Maven defines a few things called defaults. Maven follows something called convention over configuration. What this means is Maven defines a few defaults. One of such defaults is your source files should be in a folder called source main Java. Your test files should be in a folder called source test Java. We need to follow this convention to use Maven to build our projects. You can override these defaults. Maven does provide ways to override these defaults, but if you don't want to override these defaults and you would want to be similar like hundreds of other projects, then you can follow the defaults and create this particular folder structure. So let's go ahead and create the folder structure. So what I'm going to do is now create the folder. So I want to create new folder, source. I want to create a main, and inside that I want to create a folder called Java. So I've created source main Java, and I'll copy the app.java because this is the source file. I'll copy it to the Java. So source main Java, it contains our source code. Next, I'm creating another folder, source test Java. Source test Java should contain your test code. So I'm copying app.test.java and I'm putting it to source test, app.java to source main Java, app.test.java to source test Java, and I have a pom.xml in the root of the folder. So by default, the third default is when you run a Maven command, the first thing Maven looks for is a file called pom.xml. POM stands for something called Project Object Model. We will learn in detail about Project Object Model a little later. For enough, let's just assume that there's a pom.xml which is well defined. These app and apptest.java are not directly in the root folder, are not needed anymore. So I'll delete them. So because I copied them already to the other folders, I don't need them here. So I'll move them to trash, or you can do a right click. So what we have now is a pom.xml, a source main Java containing the app.java, and we have a source test Java containing apptest.java. So these are the things which we have right now. So all that we have is a pom.xml, a source main Java containing app.java, source test Java containing apptest.java. Now let's see what Maven does to make our life easy. The first thing I would need to do is cd to the root of that particular folder. In my machine, I've copied the pom.xml to this particular folder. So I've now cd to that folder. So I have to be present on the terminal in that particular folder. So I'm doing a cd to that particular folder. If you have copied it to, let's say, c:/first main project, then you need to cd to that particular folder. So this is the folder where you have unzipped your zip files, and you have to go into the first project in there, that is 0.first non-Maven project. So now I'm inside that particular project. The first thing I would want to check is whether I have Java installed properly. So I would type in java-version. Java space hyphen version. Okay, that's good. So I have a Java version 1.8 something. Java is working. That's good. Let's now check if I have Maven working. Typing in mvn space hyphen. Remember, 2 hyphens. Version. So mvn space hyphen version. If this command is working, then you would see the version of Maven which is being used. For me, it's 3.3.3. This version doesn't really matter. You can be using any version about 3.0. I think that's good enough. It shows where my Maven home is. So my Maven home directory is in this particular folder. So my Maven home is in Apache 3.3.3 directly under the root. Probably it would be c:/Maven for you. And it also shows the Java version and the Java home again. And it shows a little bit of details about my operating system. But once we get this output, it really means Maven is properly installed and you are ready to get rocking and rolling. If you don't get this output, and if you get a error, something like mvn not found, then you can follow the installation guide which is right below this video, and you can set up Java and Maven. Now we have Java and Maven set up. What we are doing right now is we have on the left hand side terminal. On the right hand side is our folder structure. Carefully observe what is getting created in this particular folder. Right now we have a pom.xml, a source main Java, and a source test Java. Now I'm going to run my first Maven command, which is mvn compile. So what I'm trying to do is I want to compile this source file. So I want to compile this source file and the test files. So let's try the command mvn compile. You would see a lot of things happening on the left hand side. It would run the command, and you would see that on the right hand side a new folder gets created. On the right hand side you would see that there is a new folder. The new folder is called target. Inside target there is a new folder again getting created. It's called classes, and in classes there is a new class file. So app.class. On the left side inside the terminal we see that we are building a project. The first command you see is resources. Let's not worry about it right now. The next thing you'd see is that it's using the Maven compiler plugin to do something called a compile. Plugins. The magic of Maven is based on a third thing called plugins. You can extend Maven and create a plugin of your own. There are a lot of plugins which are already created for Maven which help us to do a lot of things. One of them is the Maven compiler plugin. This Maven compiler plugin helps us to compile Java code. So what Maven is doing is it's running the Maven compiler plugin, compile. And you'd see that here it's compiling one source file. The one source file that we had in that folder was app.java. So the app.java is compiled and it's put in this particular folder. So target/classes. And at the end, it says build success. If there was a problem with the build, it would have said build failure. That's okay. We now compiled our first Java class. But the thing which worries me is I didn't really see the test classes being compiled. So how do I get the test classes to get compiled? So the next command is test-compile. I'm running mvn test-compile. Let's see what happens. On the right hand side, you now see a new folder. Inside target, earlier we only had classes, but now I even have test classes. And the test classes contains now a file called app.test.class. So the test file is also compiled and created. On the left side, let's now look at the log. We ran the command mvn test-compile. The first thing it was doing is resources. Let's not worry about resources right now. The second thing you can see here is it's running the Maven compiler plugin compile. So even though we just said test compile, you'd see that it's also running the compile for the source files. Because the compile was already done, it's saying nothing to compile. All the classes are up to date. That's good. The next thing you'd see is it's calling test compile on the Maven compiler plugin. So what it's doing is it's calling a test compile to compile the test classes. And you can see that it's compiling one source file. Actually, it's called source file, but actually it's a test file. It's compiling the test file to note the target. The target is test-classes. And that's exactly where this particular folder is. So there you go. So we learned now how to compile a source file and how to compile a test file. And the important thing you would have already observed is when I run mvn test compile, it runs both the compile for source files and the compile for test files. So it's compiling both source files and test files when I try to run the command mvn test compile. So that's one important thing to observe. We'll use that information a little bit later. Now, I have this target with the compiled things. I want to delete everything from the target folder. How do I do that? That's where a command mvn clean is used. Mvn clean is used to delete the target directory. You can see that the target directory has disappeared now. So the target directory no longer exists. You have done an mvn clean. Now let's run another command, mvn test. Mvn test is used to run the JUnit test files. So, but before you are able to run the JUnit test files, you have to compile the source files, compile the test files, and only then you'd be able to run the test files. So you'd see all those things happening right now. So first it's compiling the source files, then the test files, and then it's running the tests, and it says the test ran fine. So it's giving the results of that particular test. Test run 1, failure 0, error 0, and skip 0. So that's perfect. So we don't have a failures. So this is how you run tests using Maven. Now that you understood this, you are ready for a little bit of theory on what are the different build phases in Maven. In any project that we work in, before we build the jar or before we build the var, there are certain things that we do. We have to compile the source files, we have to compile the test files, we have to run the JUnit tests, then we package and create the jars, and then we would go ahead and install it or deploy it. This is kind of the sequence of steps which every project does. What Maven did is intelligently they created a build lifecycle exactly replicating these steps. So the build lifecycle in Maven is the sequence of steps that are done when you do anything in Maven. So let's say I run the command mvn test. What it does is it does a validate to make sure that the POM file is fine. It then does a compile to make sure that the source is compiling fine, and only then it runs the test. So if I do something called an mvn install, which is kind of the favorite command of a lot of developers, what Maven does is all this previous step before it. It validates whether the POM file is fine, it compiles the code, it runs the JUnit test, it packages the jar or the var and runs the verify on that, and finally installs it. So this is the build lifecycle of Maven. Build lifecycle defines what are the different steps that Maven would execute when you run a command, and you can attach plugins to each of these build life cycles. So I can say run this plugin for compile, run this plugin for test, run this plugin for verify, run this plugin for install. There are a set of default plugins which are already defined by Maven, which are inside the parent pom.xml. So we will talk about that particular pom.xml, which is called the super pom, a little later. But for now, you need to understand that this is the real build life cycle in Maven. So build life cycle is nothing but a sequence of steps that Maven does whenever you do a mvn clean install or a mvn clean deploy. There are a sequence of steps that are run in the background, and the build life cycle just defines what are those sequence of steps. Now that you have this theory, let's go back to our practical lesson. Now I would want to run a command called mvn install. Mvn install. You'd see a lot of things happening. It runs the compile, test compile, runs the test. So what it did, it created the jar here and it installed the jar to my local repository in here. This step of creating the jar is called package. That's the package step that we saw in the build lifecycle. And this step which we saw here, this step which we see here is the install command. This is the install phase in the build lifecycle. In this install phase, it's copying the created jar to local Maven repository. We'll talk about this local Maven repository a little later when we try and understand dependencies a little more. But for now, you can think of it like a folder in my machine where Maven temporarily stores the files. So what we have done is we have created the jar and we put it to a temporary repository. If you go to the target now, you'd see a jar created. So if I look at this particular jar and expand it, you'd see that it contains the app.class. So when I expanded this jar, it contains the app.class. So this is nothing but the jar which I would need to share with my friend so that they can use this particular project. And you'd see a lot of other folders also in here. So earlier we looked at classes and test classes. Now you'd see a folder called test show fire reports. Also it shows the results. So you can go to that particular folder and see that there were no failures. So the test results are put into a folder called surefire report. In the first step of our beginners Maven project, we understood what the build lifecycle is, what are the different steps that Maven runs. And we also saw the different folders which are created by Maven when we run mvn install. Next, we would move on to understand the project object model. Before that, what we'll do is we'll import the project which we have created into Eclipse. Eclipse is the IDE which we are going to use. If you do not have Eclipse installed, you can follow the installation guide and get it installed. I'm going to launch up Eclipse. So go ahead and do that. Eclipse. I'm going to create a new workspace. Workspace is basically where the Eclipse stores all the files. Don't worry about it a lot. Just type in some folder name in here for now. If this is the first time you are using Eclipse, we really recommend you to learn Eclipse further by watching our tutorial Eclipse in 28 minutes. You'll find a link to it in the installation guide. This is the Eclipse welcome screen. Let's skip that. And I would want to import the project which we have already created. So how do we do that? Is by going to File, Import. I'm typing in Maven. I would go and select existing Maven projects and click the next button. Here I would need to select the root directory of the project. So I would go ahead and browse to the root directory of my project. My project I had extracted to this particular folder. So I would go ahead to this folder and click OK. You'd see that Eclipse shows one pom.xml in here. That's fine. If it doesn't show the pom.xml, then make sure that you are selecting a project which contains a pom.xml. Now I would go ahead and click the finish button. Eclipse has beautiful integration with Maven. With Eclipse, you can import Maven projects. Eclipse can understand the pom.xml, and it can make all the things that are defined as dependencies in pom.xml directly available to this particular project. Let's look at what's happening here. Once you import the project into Eclipse, you would see a folder structure like in the screen now. So you'd see a source main Java with an app.java, source test Java with an app test.java, and our pom.xml is right here. Also, the other thing you can see is what are the different Maven dependencies that are there for this particular project. We configured a few dependencies for this project. What are those? You can see that in this particular dependencies section. So here you'd see that the dependency which is used is JUnit 4.1. To run the JUnits, we use the dependency 4.1. We will learn a little more about dependencies a little later. In this particular project, what are the different things that are useful in writing the code and in running the application? So you'd see the source folder, test folder. What JRE is used? We are using JRE 1. Even though I'm using Java 1.8 or Java 8, we see that the application is using J2SE 1.5. We'll learn how to change that a little later. You'd be able to see what are the Maven dependencies, and you'd also be able to see the target folder and the pom.xml. So this is the structure. Now let's focus on understanding the pom.xml. When I open the pom.xml, what you see on the screen is the complete pom.xml which was used to run our project. We were able to do mvn install, and we were able to compile, test, build a EAR and deploy it. We were able to do an mvn install, and we were able to compile the code, test code, run the tests, build the jar file, and install the jar file to the local repository. So all these steps we did, and all the code that was needed to do that is these 23 lines of code. Let's look at a quick structure of this XML. So you have a XSD definition, don't really worry about it. You have the definition of the name of the component in here, how it is packaged, and what are the dependencies which are used. Before we get much further, let's get a little bit of theory on project object model. So what is this pom.xml project object model? What does it really define? A pom.xml is a very, very simple XML. It's nothing but a XML with a defined structure. In Maven, the pom.xml defines, first thing, what is the name of the current project? So if another project wants to make use of our project, earlier we were talking about our project being something like Spring. So if another project wants to refer to our project, how do they refer to it? That's the name of this particular project. The next one is version. The version defines what is the version number of our current project. So whether it's 1.0, whether it's 2.0 or something of that kind. Packaging is nothing but how I would want to deliver my project. Whether it's a jar, whether it's a web application, and then it's a var. If it's an enterprise application, it's an EAR. So packaging defines what kind of a deliverable that we want to give. Whether it's a POM, a EAR, a jar, or a var. Dependencies define what are the different things our project needs. Let's say our project needs Spring, Spring MVC, Hibernate, and JUnits. So these are the dependencies of our project. So I would specify I want Spring version 3.0, Spring MVC version 3.0, Hibernate version 4.0.0, and I would want JUnit version 4.1. So those are the dependencies of our project. The other thing we would specify in the pom.xml are the different plugins. Let's say I am creating a web application. I would want to deploy the web application to Tomcat. So there's a plugin called Maven Tomcat plugin, which helps us to deploy the var to a Tomcat. The plugins help us to do a lot of such things. We earlier saw a plugin called Maven Compiler plugin, which was used to compile the code. There is another plugin called Maven Surefire plugin, which is used to run the tests and generate the reports. There are a few plugins like the Compiler plugin, the Surefire plugin. These are used by default in Maven. We can go ahead and define more plugins to be run in different lifecycle phases. A project object model defines what is the name of the current project, what is the version, what are the dependencies, what are we dependent on, and what are the plugins that we need to be able to run everything that we have in the project. Those are the important things that are defined as part of the project object model. Now that we have this theoretical background on the project object model, let's go back and look at the sample pom.xml we were looking at. The first lines define the XSDs, the schema locations, and the model.version. Let's not worry about it right now. If other projects wants to make use of our project, then they would need to use the group ID and artifact ID to use it. So that's number one. The name of the project is a combination of a group ID and the artifact ID. Group ID, you can look at it like a package. So just like the packages which we use in Java, group ID is to make sure that the artifact ID is unique. Probably just basic Maven example is not sufficient. There are other people who might be creating tutorials on Maven. So I use the group ID to distinguish and make our artifact name unique. So the name is a combination of group ID and artifact ID. Version is what version we are working on right now. If you look at it right now, we are using a version 1.0 snapshot. A snapshot indicates that something is in development. Let's say if I'm working on something right now, I'll make it a snapshot. Once I completed working and I'm sure that everything is working fine and other projects can use this artifact, then I would make the version as 1.0 and I would release a version 1.0. A version contains major version, minor version, and if I want, I can add in an incremental version. So we have a major version, minor version, and an incremental version. A major version is typically used when there is a big change in the framework. A minor version when there is a considerable change. An incremental version when there is a very small change, like a bug fix. Packaging defines how we would want to package this particular artifact as. Here, the output of this particular Maven project would be a jar. We already looked at the jar file which was created. The other options are var, EAR, and POM. We'll come to those options a little later. The dependencies define what are the dependencies I would need for this particular project. So here, I added a dependency called JUnit. I'm saying JUnit artifact is with group ID JUnit and artifact ID JUnit. And the version we want to make use of is 4.1. And I want it to be available only to the tests. So we'll learn a little bit more about the scope a little later. For now, the most important thing is we are defining a dependency. Let's see a little bit of magic with Maven dependency management now. Earlier we were talking about something called a repository, a local repository, a Maven repository. In this project, we are defining a dependency, JUnit. How does Maven know where to get this JUnit jar from? I need JUnit to run this project. How does Maven know how to get this particular version of this project? That's where the concept of a repository comes. A Maven repository stores all the versions of all the dependencies. So in the Maven repository, the different versions of JUnit are stored. So when I define a dependency, Maven would go to the Maven repository and get it and make it available to the project. And that's how you see JUnit.4.1.jar. Now, let's say I don't want to use 4.1. I want to use a new feature which came in 4.2. So all that I need to do is go here, change it to 4.2, and you would see that now in the Maven dependencies, there's a JUnit 4.2.jar which is made available. Make it 4.3. You'd see that it would take some time before it comes to 4.3, because what was happening in the background as soon as I put 4.3 is Maven went to the repository and got the 4.3 version of the file and put it in here. I'm changing it to 4.2. You'd see that the change is immediate. This is because of a concept called local repository. What happens is on your laptop or on your desktop, there's a folder which is called the Maven local repository where all the dependencies are stored. So all the dependencies which are downloaded for the first time are stored in your local repository, so that every time you don't need to really go to the Maven repository and get them. I hope that's a good introduction to how the repository system works. If you are confused about it, don't worry. We'll get back to it a little later as well. So as part of this beginner project, we learned what the power of Maven is. we learned what a build lifecycle is. What are the different steps which are invoked when I run a MVN install. We learned what a project object model is and what are the different things which are involved in defining a POM.xml. In the next section, we will learn a little bit more about dependency management, and we will look at the super POM. Next, we would move on to the intermediate Maven example. There's a project called one.basic Maven example, which is a sample exercise for you. You can look at that particular XML. It's actually the complete result of what we did with the first non-Maven project. So it shows the exact structure which needs to be there when the first non-Maven project is converted to a non-Maven project. So you can look at the basic Maven project to just get an understanding again, just to revise everything. We'll move on to the second part, the second example, which is intermediate Maven example. What I'm going to do now is I'll import this project into Eclipse and see how does it look. So similar to earlier, we start with a file, import existing Maven projects, click next. I would select the root directory. Earlier we were looking at first non-Maven project, but now we would want to import the intermediate project. So I click browse and I go to Maven, select the intermediate Maven example and say open. And you'd see that there's a POM.xml which comes up here. I would go ahead and click the finish button. Let's look at the structure of this particular project. This is source main Java. The first change which I've done is we have put app.java into a package. A package defined and app.java is in that particular package. The second change which we have done is we have the app test.java in the package as well. So that's the second change. The next thing that you would see is in the POM.xml, we have added a few more things. We have a new dependency added in, Hibernate, and we have a new section. Last but not the least, we have a new section called build. So let's look at all this stuff and understand what these really means. Let's start with new artifact. So we have added in an artifact org.hibernate and hibernate. This is the unique name to identify Hibernate. What is the version we are using? It's 3.2.5 GA. So we are adding a new version, a dependency called Hibernate. So how many dependencies do we have right now? So we have JUnit and we have a dependency called Hibernate. Let's go on the left hand side and see what's inside the Maven dependencies folder. Oh my god, there's so many dependencies. So I see a JUnit, a Hamcrust, Hibernate, there's ehcache, commons logging, but where are they really coming from? That's the first concept which we will understand. That's the concept called transitive dependencies. Let's take the example of Hibernate. My project wants to use Hibernate. So we defined Hibernate as a Maven dependency in here. But Hibernate on its own might be depending on a lot of other projects. Those are called transitive dependencies for our project. So Hibernate, for example, defines a number of transitive dependencies. You can see the complete POM file for Hibernate. If I do a command, if you press the command or control and click this particular, I'll close it again and do it again. If you press control or command and press, this is the POM.xml for Hibernate. The Hibernate POM defines the group ID and artifact ID, and it also defines the version of that particular Hibernate. That's good. But what we are really interested in is in the dependencies. So if you look at this particular thing, you'd see that Hibernate has its own dependencies. It has a dependency on ehcache. It has a dependency on commons logging. It has a dependency on JTA. So when we add a dependency like org.hibernate, we also get its dependencies for free. That's why we see things like ehcache, commons logging, ASM attributes in here. These are called transitive dependencies. So if you want to exclude a particular transitive dependency, then you can use the exclusions tag. So here I'm saying I don't want JTA. That's the reason why you don't see JTA in the Maven dependencies part of. Now you see commons logging jar in here. I don't want to use commons logging. I want to use something else for my logging framework. I would want to exclude it. So how do I go and exclude that? Exclusions for Hibernate. I'm getting commons logging because I'm using Hibernate. So I want to exclude that particular dependency. How do I do that? I can put an exclusion with a group ID and an artifact ID of commons logging. And as soon as I put it, you can see now I'm going to save it. On the left hand side, that particular dependency would disappear. So you would see that comments logging has disappeared on the left hand side because now comments logging is no longer part of the whole thing. So you would see how dynamic this dependency management is. As soon as I remove a jar, Maven is going and removing it and making it like removing it completely from the dependencies. So that's the beauty of Maven. It completely owns the dependencies and the management of dependencies. So I would want comments logging to be still there. So I'll remove this exclusion and you'd see immediately that the comments logging would come back on the left hand side into the dependencies. If you really want to see how all the dependencies are coming in, you can go and click dependency hierarchy in. So you can see the different dependencies which are resolved and how they are coming in. So if I want to know how the comments logging is coming in, I click comments logging and you would see that comments logging is coming in because it's using cache and cache is used by Hibernate. So this is the transitive dependency. We included Hibernate. Hibernate uses cache and cache uses comments logging. That's how we got it. How are we getting DOM4j? DOM4j is coming in because we have Hibernate. So these are called transitive dependencies and you can look that up by going into the dependency hierarchy in the Eclipse pom when you open up pom.xml. The next thing which we see in this particular pom.xml is the JUnit. The version control for JUnit is in a specific format in here. It uses something called a version range. So what I'm saying in here is when I say 4.1 and comma, what it really means is I would want to use any version which is greater than 4.1. So then the options which are available in here are, I can say at a maximum I want to use 4.1. So what I'm saying is I can use any version which is less than or equal to 4.1. That's how I'm defining with this. So now what would happen? You'd see that the JUnit jar which is used is 4.1 because that's the maximum that's available in the repository. When I use this bracket, it means do not use 4.1. I want to use anything up to 4.1. You can see on the left hand side, the JUnit jar which is used is 4.0. This is how you can versions. You can specify a range of versions. So I can also specify I want to use something in between 4.1 and 4.4. So I want to use anything between 4.1 and 4.4. I'll use this bracket so that it's, so you see that 4.4 is used. Usually what Maven does is it gets the highest version which is available, which is satisfied by this particular range. So I'm saying 4.1 to 4.4. So it gets the highest one which is available. Let's say 4.3 was the highest one which was available with the repository, then it would have got 4.3. So if I specify 4.20, the maximum JUnit version that is available right now is 4.2. So you would see that the jar which is present in here is 4.12. So this specifies a range of versions. So you can specify a range of versions using this particular thing. There are 7 dependencies that are needed for running the unit tests, but these dependencies are not needed for the source files. So we don't want JUnit.jar to be part of our var or a EAR. So the way we can specify that is by making a scope called test. The scope specifies where this particular jar is going to be used. So here we are saying scope is test. So that means the JUnit jar is only available for unit tests. It is not available for source code. So if you go and try to use JUnit in a source file in the source folder, it would give a compilation error because the JUnit jar will not be available for tests. As you can see, there are a few other options which are available. One is compile. So it's only available at compile time. The other one which is important is provided. When I say something is provided, it means Maven does not really need to get it. It's already present as part of the web server. So let's say a particular jar is already available in my web sphere. I don't really want to make it part of the package. So I'll call it provided. The other important option is runtime. Runtime is a very good option when you do not want your jar to be available when you are compiling the code. So when you are compiling the code, you want to depend only on interfaces and not on implementations. So if you put scope runtime, then when you compile the code, if you use an implementation, then the build would break. The other important section which we have added in this example is the build section. You'd see that there is a plugin, and the plugin defines a group ID, artifact ID as part of the build section. This is the version of the plugin that we are going to. The most important parts of the whole thing is the source and the target. This is the Maven compiler plugin which is used to compile the code. The source and the target defines what is the Java version to use for this particular piece of code, for this project. So you'd see now that when I go to the JRE system, the thing which is being used is Java SC 1.8 because I've defined the source as 1.8. That's Java 8. Let's say I want to use Java 5 for this project. I can go ahead and change this to 1.5 source and target. You'd see that you'd see an error on the Maven project. I'll do a right click, Maven update project, and press OK. You'd see that now Java version which is used is JRE system library 1.5. So this is how you change the version of Java that you would want to use. So you go ahead and change the compiler plugin to use the appropriate version. I'll go back to 1.8. Right click, Maven update project, and say OK. And there you go. We are back to using Java 1.8. So as part of this intermediate Maven example, we looked at dependency management in detail. We learned what are transitive dependencies, how do we exclude transitive dependencies, how do we specify a range of versions, and we ended up by trying to configure the Maven compile plugin to use a particular Java version. Before we move on to further things, we'll look into something called an effective POM. Just like inheritance in Java, there is an inheritance hierarchy which is defined for the POMs as well. This particular POM that we are using for the intermediate Maven example has about 60 lines of code. So it has about 60 lines of XML. Actually, it inherits a lot of things from a POM called a super POM. How do we look at what are the different things which it inherited? The way to do that is by going to the effective POM. So if I go to the effective POM, it shows the complete POM of the intermediate project with what also was inherited from the parent POM. Just like our Java inheritance, where object is the superclass for everything, there is a super POM which is the superclass for all the POMs. So whenever I create a POM, I directly by default inherit from this thing called a parent POM. And when I go to the effective POM, it shows the entire intermediate Maven example POM with the things which it inherits from the parent POM. This section is okay. Group ID, artifact ID, version, this is what we defined. These are the dependencies which we have defined. That's good as well. The most important things come inside the build section. We don't have anything, a source directory or something inside the build section. But when I look at the effective POM and go to the build section, you see that there is a source directory, a script source directory, a test source directory, a output directory, a test output directory. These are all coming from the super POM. If I don't define anything for source directory in my POM, then I would get the value from the super POM. You can see that the source directory by default is source main Java inside my entire folder structure. So if you look at the test directory, it's source test Java. This is what we looked at earlier. So if I want to change the source directory, I can go ahead and override it. So I can say my source is not this, but I want to use a source in a different place. So I don't want to use source main Java, but I want to use source main source. That the effective POM also would change. So now if I go and search for source directory, you can see that the source directory is changed. Either you can use the defaults provided by Maven parent POM. I don't do anything, and then I can go and search for it, and you would see that you get the default from the parent POM. Or you can specify something of your own for your project. The recommended thing to do is not to override the default settings. Maven uses something called convention over configuration. What it means is if every project in the world uses this structure, source, main Java. Then it's very easy for me to move from one project to another project. When I see a source main Java, I know that's where the source file is. When I see a source test Java, I know that's where the test files are. When I see a target and a classes folder, then I know those are all the results of the compilation from the Java code. If I see target and test classes, then I know that's the compilation of the test code. So Maven kind of defines the standards which all projects can use, and once every project follows this standard, then it would make it easier when I move to a new project. The other important things that you would see inside the effective POM are the definitions of the various plugins that Maven uses. So you see a Maven compiler plugin. So during the compile phase, the Maven compiler plugins compile goal is executed. Similarly, you can see a lot of other plugins configured in here. You can see that there's a Maven Surefire plugin. Which phase is it called in? The test phase. There is a Maven install plugin which is called during the install phase. A deploy plugin which is called during the deploy phase. If you looked at the length of this effective POM, I have a length of about 280 lines. I only have 60 lines inside my intermediate Maven example. So I almost got about 200 lines of configuration from the parent POM. It would be really useful if you can go through the effective POM and understand what is happening in there, because that's the default behavior of Maven. Maven defines the default behavior in the super POM. If you do not have Eclipse, then you can also look at the effective POM by using the command mvn help effective POM. Most important thing is make sure you are in the root folder of the project you are in, and you make sure that the pom.xml is directly inside that particular folder. Once you are there, if you type in mvn help effective POM, it would print the entire effective POM. Obviously, it will not be as convenient as looking at it in Eclipse. So, in the last few minutes, we learned what a super POM is and how Maven gets all the default behavior from the super POM. We also looked at how to look at the effective POM and how you can generate effective POM from the command line. Next, we would move on to something called a multi-module Maven project. The next example we'll be looking at is the multi-module Maven project. Typically, all the Java projects have a number of layers. You have a web layer, a business layer, a data layer with different dependencies. A data layer needs Hibernate. A business layer might need a transaction management framework. A web layer might need a WebMVC framework. So the needs of different layers are different, and you'd want to manage the dependencies of each one of them independently. That's where the multi-module Maven project comes into picture. You can have different dependencies defined for each of the different layers, and you can have them have their own dependencies. We'll also look at the best practices. If there are dependencies which are shared across these layers, you would want to manage them at a single place. Let's say we are using Spring in all the different layers in the project, and I want to upgrade to a different version of Spring. I should be able to do that with one change. We'll understand how we can do that. We'll understand the dependency management section of the parent POM, and we'll understand how to create a multi-module Maven project. We have the multi-module Maven project at number 3 in the folder structure. So I'll go ahead and import it right now. Same as what we were doing earlier. So go to File, Import, Existing Maven Projects. That's what we want to check. The way you can get there is by typing Existing and Existing Maven Projects. Or you can type in Maven and Existing Maven Projects. So you can use any of these ways to get here. Click Next. You can browse to the directory which you would want to go to. And I have this example in the multi-module project. So I go there. I go to the folder where our particular code is. You can see that there's a pom.xml in this particular folder, and you have business data and model. I would pick that folder and click Open. You would see the first characteristic of a multi-module project. Earlier, until now, when we imported something, we only saw one pom.xml being imported. But now, you'd see that there are multiple pom.xmls which are imported. So you have a pom.xml, a model pom.xml, a data pom.xml, and even in data there's an API and an IMPL. And you have a business API and IMPL forms. There are a total of 8 forms which are being imported. And you'd see that in Eclipse as well. You'd see that on the left hand side, once I import them, you'd have all these forms being created as a project. So you have 8 different projects which are created in here. However, you'd see that a lot of them, among them only 5 are Java projects. How do you identify the Java projects? Is by a small J. If you zoom in further, you'd see a J in here. This J indicates is a Java project. And wherever there's no J, then it means it's not a Java project, but it's something called a parent form. Let's get a high level overview of the different things which are present in here. The data layer has an API and an IMPL. The API defines the interfaces. So I have a client DO which defines the interfaces, a client DO which defines the interface. So I have a get client details and save client. This is the interface. All the other classes in here are also interfaces. The API project contains the interfaces, whereas the IMPL contains the implementation of the interfaces. It contains the dummy implementation. I'm not really connecting to a database or something. I'm just having a dummy implementation for that interface in this particular file. So it's returning some dummy values back, but we have an API and an IMPL at the data level. Similarly, we have an API and the IMPL at a business level as well. So you have a business API and a business IMPL. And we have a model. This model acts like a domain model and it's used by the data and the business layers. We will use a web layer in the next example, but the dependencies are the data layer is dependent on model, the business layer is dependent on the data and the model. So how do we really define it? How does it really work in terms of the configuration? Let's look at it. The entire configuration starts with the parent. That's basically the first form. If you look at this form, the most important part which is different is the packaging is form. In the earlier forms, we looked at packaging having jar or a var as a value. This is the first time we are seeing packaging as a form. When I see packaging as a form, then this form acts as a parent form. Just like the super form, this would be the parent form for other forms. What are those forms? That is defined in the modules section of this particular form. So what we are saying here is this form is a parent form. Basically what we are saying is this form will set the properties, set the dependencies which might be needed by these particular modules, data and business as the modules. So we have 3 folders called model, data and business, and they have their own forms. So if you look at business, it has its own form. Data, it has its own form.xml. Module, it has its own form.xml. So 2 things to remember in here. One is the folder name. The folder name should exactly be the same as whatever we have as the module name in here. So when I say module model, here the folder name should be model. Let's move inside the business IMPL. If you look at this particular form, we are defining the dependencies inside this. We have a dependency on the multi-module model which we have created. It has a dependency on the multi-module data API which we have created. It has a dependency on multi-module business API and the other Spring framework, so Spring Beans, Spring Context and other things like that. One thing you would have noted here is I'm not specifying any version in here, but still there is no compilation error. So in the dependencies I'm not specifying any version, but still it's not giving me an error. This is because in the parent form, in the topmost level parent form, the dependency management section of the parent form specifies what version of dependency I would need to use for the entire project. So if I'm using Spring in any of the layers, business, data or model, it would use the same version. So I'm specifying the version in here. So you'd see that for AOP, I'm specifying the version 4.1.6 release. So in business IMPL, if I'm using AOP, then it would use this version. I'm specifying the version for all the jars in here. You'd see that the version of jar which is used is the same at multiple places. And if I want to change from 4.1.6 to 4.1.7, Still, I would need to go ahead and change in multiple places. So how do we avoid it? That's where Maven comes up with this thing called a property. So you can define a property in a parent XML or normal XML. You can define a property in any XML. So here I'm defining a properties. In the properties, I'm defining a property called Spring Core version and Spring AOP version. And I can use these properties by typing in $ and pasting this Spring thing. I want to use Spring AOP version in here. Both of them have the same values actually. So I could have used any of them in here. So instead of 4.1.6 release, I'd want to use Spring AOP version. Similarly, we use the specific Spring version in here. The other thing you can look at in this pom.xml is we use a variable called project.version. Project.version refers to the current project's version, because the model, data and business are part of the same project. Why do I need to create separate versions of each one of them? So I will use the same version as the current project. So in the dependency management, I put it as project.version. So this is how you can do dependency management in a multi-module project using Maven. Let's now go ahead and go to the command prompt and run this particular project. So I'm doing a CD to that particular folder in terminal. You can use command prompt in Windows. And I'm doing mvn clean install. You can see the magic unfold. So I have the business layer open on the right side. So you can see that Maven goes ahead and builds all the children forms as well. So when I run mvn clean install at this level, what Maven does is it sees that there are 3 sub-projects, which are business, data and model. It goes to business and sees that business has 2 sub-projects, and it sees that business has 2 sub-projects defined in the pom.xml, API and IMPL. Then it goes to API and sees that there is a pom.xml. So it goes ahead and runs the build for all the things which are present in here, and it shows you a summary. Let's maximize this and see what's the summary. So you can see that when I did a mvn clean install, it ran the parent, it ran the model, then it went to the data API, data IMPL, business API and business IMPL. So basically what Maven did is, from the parent POM, it identifies the child POMs and it runs all the child projects. It's like a tree structure. So all the projects in this tree structure are linked together by using the parent POM and the module level POMs. You can see that all the JUnit tests that were there are also run. So if I have tests at data IMPL, business IMPL and in model, all of them would have run as part of this. So what we have looked at in this example is how multi-module projects are configured in Maven and how you can do the dependency management at single place in a multi-module project. What I would recommend you to do is to go through the entire project and see if you have any questions about how the pom.xml is structured. The last project we'll be looking at during this tutorial series is developing a web application with Maven. I have a sample web application developed and made available for you inside this particular folder. So it's for web application with Maven. That's the folder you need to go to. So I would go to that particular folder in here, CD. I'm inside that particular folder right now, and I can run mvn clean install. So it would build the project. It would make sure that the project is built. While it's building, let's spend some time looking at the structure of it. So if you open the pom.xml, you'd see that this contains 3 modules. One is called the core, the other one is called web common and web servlet.js. When to right click import Maven projects or file import Maven import and go to import Maven project, I have browsed to the appropriate folder. So for web application with Maven, that's the project which we want to download. We have a pom.xml and it has 3 sub projects in there. So all of them would be imported right now when I say finish. In 28 minutes, mvc-pom.xml This contains three modules defined in here: core, web common, web servlet JSP, and the packaging is POM. So the core defines the backend functionality. So it contains how to launch up Hibernate, what are the business services exposed, and things like that. The application we have created in here, we have created it with using web servlet and JSP. We have already created the same application also with struts and Spring MVC. Those tutorials are also available. We wanted to use something as common for all these things. So when I'm developing something with web MVC, when I'm developing something with struts and Spring, I don't want to repeat all the things in every project. So what we have done is we created a web common project which contains all the common things between these projects. So the web common contains all the common things between these web projects. Here we are looking at one version of it. We are looking at web servlet JSP, which is the normal JEE, default JEE implementation. So if you open up the in 28 minutes web servlet JSP pom.xml, you'd see that the packaging is var. This is the first time we are seeing a var project in this tutorial. So when I specify a packaging as var, the entire project is packaged as a web application archives, and all the dependencies of this particular project are mentioned in here. You can see a dependency on web common, and you can see a dependency on the Java EE web API. So we put the version as, we are using JEE 6, so the version is 6.0, and as you know, this would be provided, scope should be provided, because this API should be provided by the application server or the web server where I'm deploying this application. So I'm putting the scope as provided. I don't want to include this particular jar as part of my deliverable. I don't want to have this particular thing in my var file, but to compile it I would need it. So I put the scope as provided. When I say something as provided, then the jar is not made available when inside the package. So inside the var, this jar will not be available. Now let's go ahead and run mbn clean install for this project. So I'm going to run mbn clean install for this particular project. When I run mbn clean install on the parent project, you'd see that the sub projects are also built along with it. So the core, the web common, the web servlet JSP, Maven web app, all these of them are built. Let's go to the target folders of each one of them and see what's really. If I go to the core and see the target, there is this in 28 minutes core 1.0 snapshot jar which is built. For the common, also we configured it as a jar project. So you'd see that there is a jar file which is built in. For the JSP, however, we specified the project type as var. So you'd see that there is a in 28 minutes var that was created. There is also a folder called in 28 minutes in here. So if you go there, you'd see the content of this particular var file. So you'd see actually the entire content. So this var file, like if you look at the workspace, there is a CSS, there is also images, JavaScript, and also there are a lot of classes which are there. All the lib files which are part of the var are also present in here. Just spend some time looking at this folder to get a complete understanding of what is inside a var file. So when you specify a project type as var, it actually takes all the dependencies and puts them into a webinf folder, into a lib, and all the dependencies are made available in here. All the classes in this particular var are present inside the classes folder. What happens at the end is this var is created with all the content that we see in the earlier folder. So in addition to classes, test classes, and things like that, we have a folder created with the same name as the var file, which contains all the things that would be part of the var file. And finally, a var file is created. This is the var file we want to deploy to Tomcat and run. How do I do that? So the way I would run that is by using mbn tomcat 7 run. The thing is, I have a Tomcat 7 plugin configured as part of our project. So if you go ahead and look at the topmost level parent POM. That's this one. So inside the root folder directly, if you look at this, you'd see a Tomcat plugin defined. So we have a plugin defined in here called Tomcat plugin. We have configured it to use the var file. So we are saying use the var file in target in 28 minutes.var. The context root for this particular project is /. So when I type in localhost 9080, which is the default, I would get the project. And I use the context reloadable as true, so that whenever I make a change in the application, it's directly deployed to the Tomcat server. So because I configured this plugin in here, I'll be able to use this command mvn tomcat7 : run, and I would be able to run the application right now. So look at how simple it is. What happens in the background? This command might take a little while to run, because what Maven does in the background is it downloads the entire Tomcat server. So it goes to the Maven repository, downloads the entire Tomcat server, and then runs the application, deploys the application in Tomcat, and runs the application. I've opened up my Firefox and I'm launching up localhost :80. The application runs. That's great. So the username and password is it's user@in28minutes.com, and the password is password. So it's just PASSWORD. You can find the username and password in a file called data.sql. So if you do a Control-Shift-R and type in data.sql, you can get to this file. The username and password are in here. So this is the username and this is the password. If you go ahead and type in, you can go sign in and you can manage your to-do list. This is a sample application that we created for our web application tutorial. We created this application using Spring MVC. We also created this using struts, and we created using JSP servlets and also AngularJS as well. So this is the sample application we use to demonstrate all our tutorial. If you like this application, do look out for our tutorials on Spring MVC, struts, and web applications, and AngularJS as well. You can go ahead and delete the to-dos or do anything with it. I'm deleting them. I can see how many are pending, how many are. So this is a typical Java application. You can see how easy it is to launch a web application using Tomcat. In the command prompt, when I say Ctrl+C, this server gets stopped. Now the application is no longer running. And if I want to reload again, I just say mvn tomcat7 run, and the application runs again. So there you go. That's the application launched up again. So in this tutorial, we looked at how we can launch a web application using Maven. We used mvn tomcat7 run to run this application. In the last part of this tutorial, tips and tricks, we will look at a few important commands which you can use. I'll use the intermediate Maven example project to show these commands. So, we can do a mvn clean install. It would compile, it would run everything, it would build the jar, it would do a lot of things. Let's say you have a problem while doing this. You want more information from Maven. The way you can get more information from a Maven build, more information printed out to the console, is by using the debug option. So if I do a mvn-x and the commands, you would see that a lot of information is printed to the console. So this is the way you can print a lot of information to the output. So when I did mvn-x clean, you'd see that first it's printing the Maven version, the Java version, and then it's printing a lot of debug information. So it's saying what are the lifecycle events that are triggered, what is the build plan, what is the configuration which is used, and a lot of debug information is printed out to the console. So the command is pass in a parameter called -x and type in your usual command. So if I want to do mvn clean install, so I'll put mvn-x clean install, and it would print all the debug information. The next command is mvn effective POM. We know that the POM inherits from a super POM, and the mvn effective POM command prints the entire POM. So the POM.xml inherits from a super POM. So it prints the entire POM including the super POM. The next command which we would learn about Maven is mvn help : effective POM. We saw this command a little earlier. We use this mvn help effective pom command to print the entire pom. We know that the pom.xml inherits from a super pom, and there is a lot of configuration in super pom. So how does the XML look when super pom and the current pom are combined? So that's what you can see when you type in mvn help effective -pom. It would print the entire effective pom. So you can see a big pom printed in here. So this, you can see the source directory, this test source directory, and all the plugins which are used, everything when you type in mvn help effective pom. The next command we will look at is mvn dependency -tree. mvn space dependency :tree. Be careful with the spelling for dependency. This prints the entire dependency tree to the output. As we talked about earlier, when I depend on something, the dependency itself might have its own dependencies. For example, I depend on Hibernate. Hibernate has its own dependencies. So we want to see the entire tree, dependency tree. That's how you do it. mvn dependency :tree. So this information you can also get by going to the dependency tree tab in Eclipse. Once you open the pom.xml, you can go to the dependency tree tab to look at this information. But if you want to look at it from the command prompt, you can use this command, mvn dependency :tree. So you'd see that the project depends on JUnit and JUnit uses Hamcrest. And you'd see that the project depends on Hibernate and Hibernate uses all these dependencies. So mvn dependency :tree. Sometimes you would want to see the source file of the dependency. So I want to see what's the source of a Spring framework. I want to download the entire thing and make it available so that when I'm debugging something, I can debug through Spring's source. So how do I do that? That's by using the command mvn dependency sources. What it does is actually downloads the sources for all the dependencies. So you can see that it's downloading the source for JUnit, it's downloading the source for DOM4J, and it would go ahead and download the sources for every project which is in there. If you run it on a big project, this would take a little while because it downloads the entire source file. You can see now we are downloading the Hibernate source code as well. So now we are done with downloading all the sources. Now we can go ahead to Eclipse, and if you look at there, you would have the source files available when you debug something. The next command we would be looking at is mvn help effective setting. When you are using Maven, you would want to find about your local settings. Where is my local repository? Where is the local repository where my Maven files are temporarily stored? That's the mvn help effective settings. So it shows the settings which are used by Maven in your system. So you can see that my Maven repository is at users rangarao.karnam.m2/repository. So this is where my local Maven repository is. Actually, we can go to that particular folder and see what are the files which are present in there as well. I'll open up that folder and you'd see that there are a huge list of files which are downloaded to this particular repository. So in this folder, all the jars that are there. So if you go to org Spring Framework, all the Spring Framework jars are downloaded in here temporarily. So what happens is whenever I specify a dependency, the dependency first gets downloaded to this folder and then is made available to this project. So that whenever the same dependency is needed by any other project, we don't really need to go to a Maven repository on the internet and get it. So that's the command mvn effective settings. It helps us find where our local repository is. The last but the most important Maven command is Maven archetype. I want to create a small Java project using Maven. Should I go and create the entire pom.xml myself? No, you don't really need to do that. You have something called a Maven archetype. The Maven archetypes can be used to generate projects. There are hundreds of Maven archetype projects which are present, which can be used to generate any kind of project. So let's say I want to generate a sample project for Spring MVC. There's an archetype for it. How do you find out what are the archetypes which are available? So the command for generating archetypes is mvn archetype : generate. it actually lists a huge amount of things. So it shows you a list of things that are there. I mean, it gives you a big list of archetypes that are present. So you'd see that there are about 1356 archetypes which are present in here. I'll use the default one. The default one which is suggested to me is 609. Let's see what that is. So next it's asking me for a version. I would use the latest version which is 6. So I'll go for 1.1 version. I'll type in 6 and it asks for group ID. So I'll type in com.in 28 minutes dot dummy and artifact ID. What's the name? So I'll call it a dummy project. By default, it suggests the version 1.0-snapshot. I'll go ahead and use it. And also it's asking what should be the package. I'll go ahead and use what it suggests. And I press enter. Now you'd see that it is creating a project for me. Let me do a ls. So you'd see that there's a project which is created which is called dummy project. And I can go and cd to that. And let's try ambient clean install. So the build is now success. What I'll do is I'll go ahead and import it into Eclipse. So I've created this in a folder called temp. So I'll go there. I'll open up the dummy project, click open and click finish. So you'd see that the dummy project is now imported. So you'd see that there is a package which is created with the package name that we gave. There's app.java, apptest.java in here, as well as there's a pom.xml created with the settings that we gave when we created the archetype. So you'd see that the group ID, artifact ID that we provided when creating the archetype, when we are creating the project using the archetype, is present in here. And the version we have specified. And it has a few dependencies. And this is a sample project which we created using the Maven archetype. Similarly, there are a lot of other projects that you can create. So you can go ahead and search the archetypes and see which archetype can be useful for you. There are a lot of archetypes, and I recommend to take a look at all of them and see which of these you can use for your projects. In this tutorial, we started with understanding what is Maven. We went to the beginner Maven project and understood what is the power of Maven. What is the project object model? What's the build life cycle? We understood the concept of superform and transitive dependencies with the intermediate Maven project. We went to the multi-module project and understood how you can configure a Java project with multiple modules. Then we looked at a web application. We ran it in Tomcat and saw how easy it is to run web applications using Tomcat when you are using Maven. At the end, we looked at what are the tips and tricks in using Maven. What are the useful commands which you'd use in situations where you have problems. We loved creating this tutorial for you. We hope you loved it too.